My name is David Regalado. I recently joined a startup where I serve as a VP of engineering. We're building an awesome product using generative AI. I'm the founder of the Data Engineering LATAM community, the biggest, fastest growing community in Latin America. I'm also an ambassador at AI Time Journal. What we have here is the Lambda architecture. The way this works is that an immutable sequence of records is captured and fed into a batch system and a stream processing system in parallel. You implement your transformation logic twice, once in the batch system and once in the stream processing system. You stitch together the results from both systems at query time to produce a complete answer. The problem with the Lambda architecture is that maintaining code that needs to produce the same result in two complex distributed systems is painful. Programming in distributed frameworks like Storm and Hadoop is complex. Inevitably, code ends up being specifically engineered toward the framework it runs. It was a nightmare. Duplicate data and logic. Data in the Lambda architecture is written twice, leading to duplicated logic and implementation in both the speed and batch layers. Dual execution paths. The architecture requires separate execution paths for streaming and batch, creating a maintenance challenge with multiple frameworks, components, and clusters. Code divergence. Lambda architectures often results in code-based divergence, as bad code works on finite datasets, while real-time stream processing operates on an infinite event stream. Diverse skill set requirement. Managing the platform demands developers with diverse skill set, diverting attention from core business problems. It kind of feels like playing the whack-a-mole game. So no one wants to waste their time either searching for talent, training in-house teams, or learning technologies over and over again. Introducing the unified Apache Beam model, the easiest way to do batch and streaming data processing. Write once, run anywhere. Data processing for mission-critical production workloads. While with Lambda architecture, data engineers are forced to master a set of technologies for data processing, with Apache Beam, you can do the same, but in a simplified way. The unified programming model consists of the following. Batch processing and streaming processing are the processing type, and we will see later that with Beam, you no longer have to think on the Lambda architecture scenario. Every big data processing framework like Apache Spark, Apache Flink, Google Cloud Dataflow, etc., is an execution runner, and the implementation details are transparent for the developer, meaning that it just works. Every programming language like Python, Go, Java, SQL is a SDK for writing Beam code. BigQuery, MongoDB, Elasticsearch, S3, Cassandra, Redis, and many, many more are the sources and sinks for the Beam model, provides the corresponding I/O connectors. Who uses Apache Beam? Apache Beam is used by LinkedIn, is used by some major banks and other big companies, and the results that they are reporting is something like we handle trillions of events daily, we reduce time by X times, and we reduce cost. So it is really have been getting a little traction. Some of these users are really, really happy implementing this way of programming. Apache Beam's programming model uses higher level abstraction that lets you focus on your application logic, not how to cram your application logic into an underlying framework. Instead, you build a pipeline as an arbitrary graph that mixes custom element-wise processing with aggregations and library functions. Beam pipelines can process both bounded fixed-size datasets as well as infinite streams of elements. And when you write your application logic, you don't need to worry which type of collection you'll be processing. This makes your pipeline and logic very flexible and reusable. Now, to truly unify batch and streaming processing, we need to separate the notion of event time from processing time. Event time is the time an event happened. The Beam model is based on 4 key questions. What results are calculated? Are you doing compute sums, joins, histograms, machine learning models? Where in event time the results are calculated? How does the time each event originally occur affects the results? Are results aggregated for all time in fixed windows or as user activity sessions? When in processing time, the results are materialized. Does the time each event arrives in the system affect the results? How do we know when to emit a result? What do we do about data that comes in late from those pesky users playing on transatlantic flights? And finally, how do refinements relate? If we choose to emit results multiple times, is each result independent and distinct? Do they build upon one another? The goal in Beam is to fully support 3 different categories of users. End users who are just interested in writing data processing pipelines. They want to use the language that they want to use and choose the runtime that works for them, whether it's on-premise, on a Zoom cluster on the clouds, or on a fully managed service. In addition, we want to develop stable APIs and documentation to allow others in the open source community to create Beam SDKs in other languages and to provide runners for alternate distributed processing environments. So, by using Apache Beam, we can reduce costs by maintaining just business logic and not worrying about how to cram business logic into an underlying framework. The need for diverse skill sets reduced dramatically. We don't have to spend our time thinking about different data architectures and data processing frameworks. It just works. We can get our time back as engineers. No more whack-a-mole game. So, this is what I call the theory of everything for data processing. I encourage you to visit and bookmark these URLs.